Hello class, welcome to Unit 7, Lesson 1. Today we're going to be evaluating functions. Your learning target is that you can evaluate functions at numeric values and algebraic expressions. Okay. So first of all, what is a function? A function is the dependence of one quantity on another. Okay. This wording, as a function of, comes up a lot. Whenever you see as a function, is a function of, the y value is always listed first, okay? If you guys think about, a linear, y equals 5x plus 2, it's always y, and then it lists a function with x values, or an x variable. Oh my gosh, excuse me. So it's a y function, and it lists a function with x values in it, okay? Same thing with your quadratic, 2x squared minus 3x plus 4, okay? Y equals a function with all of its x's. So the y value is always listed first. So y as a function of x. Height as a function of age. So they're saying your y-axis would be your height, and your x-axis would be your age. So y, x, and in this case it'd be height and age, which makes sense, right? If you plug in your age to a certain point, then you can get out your height. The cost of mailing a package as a function of its weight. Okay, area of a circle as a function of its radius, or is a function of. But always the y value is listed first, and then the second one is your x value. Okay. So a function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. Okay, so what we're talking about here is your domain and your range. Okay, those are your x values. And then your range is your y values. In order to be a function, okay, you have to have a rule that only assigns each x value to one y value. Okay, if I have an x value, let's say the number 2, and I have the point 2, 0, and let's say I have the point 2, negative 1. If I plot 2, 0 and 2, negative 1, if you guys remember the vertical line test, would this be a function? No, because the rule assigns more than one y value to each x value. Okay, so this one does not pass the vertical line test. It goes through more than one point at a time. So this is not a function in this case. Okay. However, if all your x's are only going to one y, then you're in good shape. Okay. Could you have an x value here, let's say 2, and an x value here, negative 2, that assigns to the same y value? Is that okay? You should be thinking to yourself it is, because guess what? I can even draw this. This is a parabola. So it's fine to have the same y value, but it is not okay to have two x values. Okay, if that happens, then it is not a function. Okay, so some things you can look at a table to determine if it's a function. You could look at the vertical line test. Remember, you run a line across it, and if it only touches at one point, it's a function. Those are things that make it a function. Okay. So here's a function. It's a parabola. I would agree if I graph this, it's going to be a parabola going up, and it's a function. So the newest thing is that we have function notation. Okay, so this is f of x equals 3x squared plus x minus 5. So really we used to have y equals 3x squared plus x minus 5. But now it's calling it function f. So f is kind of like naming it, because you're going to have f of x. Eventually you'll have functions g of x, h of x. So it's kind of a way to name the function, but it's also telling you you're taking this function and you're plugging in x's to it. Okay? And in this case, it's telling us specifically in the spot of x to put the number negative 2. So to find f of negative 2, you do 3 parentheses negative 2 squared plus negative 2 minus 5. You can type this into your calculator as much as, or exactly like that if you want to. You can also just do it. Really, I have 3 times 4 minus 2 minus 5. So I have 12 minus 2 is 10. 10 minus 5 gives me 5. Okay. So my answer would be 5. The other thing is what I plugged in, this is your input. It's also your x value. Okay. And this is what we call our output, and what we got out was our y value. Okay. So input and output. How about f of 0? Let's find f of 0. plugging in 0 for my x's. So we have 3, 0 squared plus 0 minus 5. Well, this is going to give me negative 5. Plugging in 4, I'll have 3 times 4 squared plus 4 minus 5. So this is 16. 16 times 3 will give me 48 plus 4 minus 5. So 52. 52 minus 5 gives me 47. The next one is not as nice because it's a fraction, but we'll all be okay. So I'll have 3 times 1/2 squared plus 1/2 minus 5. And what I would do is, you could type it in your calculator. You could also do it by hand. Put it in and then go math frac if you did it in your calculator. So this is really 3 times. 1 squared is 1, and then 2 squared is 4, plus 1/2 minus 5. This is 3 over 4 plus, I know I'm going to have to combine these, so I'm going to get a common denominator. It'll be 4. So I will have 2 over 4 plus a negative 20 over 4. So my final answer will be over 4. But I have 3 plus 2 is 5. 5 minus 20 gives me negative 15 over 4, and then I would just reduce it if I could, but I can't. Okay. So there is example 1. So this is function notation. It's telling us what x value to plug in, and then we're getting out a y value. Example 2. Now we're plugging in not numbers, but variables. So we need to plug in our variables and we need to simplify. So what it's saying is wherever there is an x, we are going to write an a. So this equals 2, and then I have a squared plus 3 times a minus 1. I would just simplify this. I don't need the parentheses. It'd be 2a squared plus 3a minus 1. And that would be your final answer. The next one, I'm going to go ahead and plug in negative a. So I'll have 2 parentheses negative a squared plus 3 times negative a minus 1. When I simplify this, it's really a negative 1 and an a. If I square a negative 1, I will get positive 1. So this is really going to be positive a squared. Okay, so it'd be negative 1 squared and a squared. This is positive 1 times a squared, which will just leave me with a squared. Then take it times 2. So this will be 2a squared, and then 3 times negative a, negative 3a minus 1. And the last one, we are plugging in a plus h wherever there is an x. So we got to plug it into those 2 spots. So we will have 2 parentheses a plus h squared plus 3 parentheses a plus h minus 1. And you must simplify this. And in order to simplify this, you must write it twice and you must FOIL it out. So we will have 2, and then we're going to have a plus h times a plus h. And then I'm going to distribute my 3. So plus 3a plus 3h minus 1 from distributing. Now I'm going to FOIL this piece. So it's going to be 2 parentheses. A times a is a squared plus a times h is AH plus H times A. You could write HA or AH. I'm going to write it as AH. And then lastly, you'll have H times H, so plus H squared. Then plus 3A plus 3H minus 1. I have AH plus AH, so now I will have 2 AHs. Can combine those. Nothing else in here can be combined. So I'm going to distribute my 2 now. So I will have 2a squared plus 4ah plus 2, sorry, this is going over here, h squared. And then I'll have plus 3a plus 3h minus 1. I do not see anything that I can combine here. So we are done. That is your answer for that one. It's a nice answer. All right, let's look at example D. Okay, we are evaluating, and actually this is the same function from before, f of a plus h minus f of a all over h. And it's telling me h can't equal 0. Why can't h equal 0? Because you can't have 0 in the denominator. If you have 0 in your denominator, it is an undefined value. If you take any number divided by 0, you just cannot do it. But the good news is we just did this in part C. If you go look back at part C, f of a plus h, that was our answer. We also did f of a in part A. So I am going to go ahead and plug those in, our answers, from the previous slide. Okay, so writing down my answer from part C, we had 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. So when you plug this in, this is going for this part, put it all in parentheses. Now minus, we are going to subtract the next part. So put that all in parentheses, f of a. This is where people forget because you have to subtract everyone eventually. So f of a will be 2a squared plus 2a minus 1. And then this will all be over h. Okay. So we are going to go ahead and distribute our negative, and then we're going to see if anything cancels. So this equals, and then we'll have the first part will stay the same. I'm not changing that at all. So just rewriting. Minus 2a squared minus 2a, wow, plus 1. That's a plus 1. All over h. Okay, then I would just say to myself, does anything cancel? And here is like a very, very large hint if you've made a mistake. This second piece should all cancel, okay? Things should cancel very, very nicely. I wrote down the wrong letter, didn't I? My bad. This should be a 3, right? This should be a 3. And now it'll cancel. So we got our 3a's. So there you go. I found out I did a mistake because I knew it should cancel. And there's that. Now if I look at what I have left on the top, I have 4ah plus 2h squared plus 3h all over h. I would notice that all of these have an h in them, so I'm going to factor out an h. So I'll have 4a plus 2h plus 3 all over h. And then you should see those h's will cancel. And my final answer will be 4a plus 2h plus 3. Okay. This is what we call the difference quotient, this type of problem. And you will see it a lot more this trimester. And if you're going into calculus, you will see it a lot in the very beginning of calculus. Okay, so here it is again, except for this one's a little different. Evaluate when I have f of x equals -2. Okay, so I'm plugging in a for any of my x's, but this function has no x's. So no matter what a I plug in, I get out -2. Here, I'm plugging in a plus h. Okay, no matter what I plug in, there's no x here. I'm still going to get out -2. So if I go ahead and plug what I have here in, I will have f of a plus h for this problem. So -2 minus my f of a, -2 all over h. I will get 0 over h, which is anything, 0 divided by anything is 0. So my final answer for that one is 0. Okay. Example 4, your favorite kind, fractions. There's going to be some common denominators in our site. Okay. So let's first find f of a. Wherever there is an x, I'm now going to write a. So I will have 1 over a plus 2. Then I'm going to move on to b, a plus h. So wherever there is an x, I'm going to write a plus h in the spot of this x plus 2. I can't combine any of that stuff, so I'm just going to write it as a plus h plus 2. No parentheses are needed. And then c, I am taking my answers from part A, and I am going to plug them in. So f of a plus h is what I write first. So I have 1 over a plus h plus 2 minus f of a plus 2. all over h. So you guys did stuff like this in Pre-Calc 1. You have fractions within fractions. So the first thing I am going to do is I am going to keep my focus on this very top fraction. Okay, and in order to put them together to make one fraction, I'm going to get a common denominator. Okay, so my common denominator, this one has an a plus h plus 2. This one does not, so I'm going to take the top times a plus h plus 2, and in order to get my common denominator, I also must do it to the bottom. Then if I look at my left-hand side, over here, to make them look the same, this has an a plus h plus 2, and so does this, but this side has an a plus 2 and this one doesn't. So a plus 2 to the top and the bottom. Now that I have a common denominator, your denominator stays the same, and my numerators I can write as 1. Okay, so I will have, this will equal a plus 2 minus, and now I will have a plus h plus 2 all over my common denominator, which is a plus 2, and a plus h plus 2, and then don't forget all over the h. Okay. Then from here, I would distribute my negative. Okay, so I have a plus 2 minus a minus h, and then lastly minus 2. All over my common denominator again, a plus 2, a plus h plus 2. All over h. Same idea as the last problem, or sorry, 2 problems ago. When you distribute your negative, things should cancel very nicely. Okay, and so here I see my a's will cancel and my 2's will cancel, and all I am left with is a negative h. Okay, so here is my top fraction, and essentially this bottom one is my bottom fraction. I'm going to think about it as h over 1. If you have a fraction being divided by another fraction, really what you do is you multiply by its reciprocal. Okay, so I'm going to take and rewrite my first fraction. We got negative h, then we got a plus 2 and a plus h plus 2. And I don't want to have to be dividing again, so I'm going to multiply by this reciprocal, which is 1 over h. And I should then see that my h's will cancel. This simplifies to be negative 1 times 1, so I'll have negative 1 on the top. And my common denominator is a plus 2, a plus h plus 2. And there is example 4, simplified. Okay, when you have those fractions within fractions, I know it can get a little tricky. Okay, so be careful on the algebra of that one. But what we did was we plugged in our information from a and b. Okay, then you got a common denominator for the very top fraction. Okay, we simplified the top piece, and then we multiplied by the reciprocal of the denominator. Okay, but same idea. Once you distribute that negative, things should cancel. If things aren't, you've made a mistake. So go back and double check your work. Okay. That is it for Unit 7. The change, though, is we are starting, this is our first assignment out of the book. So if you have a textbook, you can go ahead. It's going to be on page 155. Otherwise, I put the PDF page number on there because like sometimes if you put go to in your iPad, you can put 184 and then make sure the actual book has the page 155. And on there you guys are going to do problems 29 through 36. If you have any questions, just feel free to message me. Otherwise, have a good day and I'll see you later.